Okay, so we're going to talk about enzymes and substrates, how they interact with each other, and the types of reactions that can occur. If you just take a look at our enzyme right now, we notice that there are charges on our enzyme, negative and positive here. Those are charged amino acids. Because remember, an enzyme is a protein, and proteins are made out of amino acids. We also have this yellow here, this active site. So there's a specific configuration for this enzyme which needs to match up with a specific configuration on the substrate as well in order for the reaction to occur. So let's take a look at a substrate that is built for this enzyme and vice versa. Here we can see the active site configurations work out, and we also see that the charges are opposite, and opposites attract. So that's going to hold that substrate into the active site there. Now, there are substrates that may have the same shape, but the active site configurations are not the same, they're not in the same location, and also the charges might differ as well, which if you have like charges, you're going to be repelling the substrate from the enzyme there. So let's take a look at a few types of reactions that can occur. The first one we're going to take a look at is a catabolism. Now, in catabolism, what we're going to end up having is a substrate that will enter the enzyme, and the enzyme will then go through hydrolysis, and water will be inserted and added, which will allow for the breaking of the bonds to happen within this substrate. Now, when that happens, we will now then have two pieces come out, two products now. Okay? That is catabolism. And again, hydrolysis helps aid in that dismantling of those bonds of this substrate to break it down. Now we can think of this as like a disaccharide, where an enzyme such as amylase would come in and would take the disaccharide and help break it down into two monosaccharides here. All right? Remember, hydrolysis aids in that. Hydro meaning water and lysis meaning to break apart. Now we also have anabolism, and in anabolism it's a little bit different. It's kind of the opposite, where you have one piece of a substrate go in, and then you have a second piece fit in, kind of lock and key there, and now you have one whole piece. Now in this way we are now creating bonds, we're making bonds. The enzyme is making bonds. Dehydration synthesis, so we're going through opposite of hydrolysis. We're going to dehydration synthesis, where when these two come together and they fit together, water is then released, and these two molecules will then bind together, and then it'll be released. There you go. So we've just covered a few things here. One, the active sites need to match up, the charges need to match up, even the shape needs to match up. For instance, if we had an enzyme here, this enzyme was not made for this substrate. Okay, we can see that because the shape just does not fit. So that would be an example of a substrate that's not made for that enzyme. So enzymes are made specifically to work with specific substrates. So we're going to reuse this piece here again, but now we're going to use it as an inhibitor. Now what the inhibitor will do is it will go in, and this is a non-competitive inhibitor, where it will enter the enzyme and it will change the shape of the enzyme. The enzyme will then not be able to allow the substrate to enter. So it's not competing for the same active site, so we say it's a non-competitive inhibitor, but it is changing the shape of that enzyme there so that this substrate cannot enter and the enzyme cannot do its job. There are also competing inhibitors, and in a competing inhibitor, it will come in and it will enter the active site, and it will block the substrate from coming in. That is a competing inhibitor there. So again, this enzyme cannot do its job. In this case, this is now inhibiting the substrate from entering the enzyme. All right, so those are the basics of enzymes, what they do, how they act, the types of reactions that can occur, and then also what can inhibit those reactions as well.